Aramid fibers are a class of heat-resistant and strong synthetic fibers. They are used in aerospace and military applications, for ballistic-rated body armor fabric and ballistic composites in bicycle tires, and as an asbestos substitute. The name is a portmanteau of aromatic polyamide. They are fibers in which the chain molecules are highly oriented along the fiber axis, so the strength of the chemical bond can be exploited. History: aromatic polyamides were first introduced in commercial applications in the early 1960s, with a meta-aramid fiber produced by DuPont as HT1 and then under the trade name Nomex. This fiber, which handles similarly to normal textile apparel fibers, is characterized by its excellent resistance to heat, as it neither melts nor ignites in normal levels of oxygen. It is used extensively in the production of protective apparel, air filtration, thermal and electrical insulation, as well as a substitute for asbestos. Meta-aramid is also produced in the Netherlands and Japan by Teijin under the trade name Konix, in Korea by Toray under the trade name Arawan, in China by Yantai under the trade name New Star, by SRO Group under the trade name X-Fiber, and a variant of meta-aramid in France by Kermel under the trade name Kermel, based on earlier research by Monsanto Company and Bayer. Para-aramid fiber with much higher tenacity and elastic modulus was also developed in the 1960s-1970s by DuPont and Akzo Nobel, both profiting from the knowledge of rayon, polyester and nylon processing. Much work was done by Stephanie Pollack in 1961 while working at DuPont, and the company was the first to introduce a para-aramid called Kevlar in 1973. A similar fiber called Twaron with roughly the same chemical structure was introduced by Akzo in 1978. Due to earlier patents on the production process, Akzo and DuPont engaged in a patent dispute in the 1980s. Twaron is currently owned by the Teijin Company. Para-aramids are used in many high-tech applications, such as aerospace and military applications, for bulletproof body armor fabric. The Federal Trade Commission definition for aramid fiber is a manufactured fiber in which the fiber-forming substance is a long-chain synthetic polyamide in which at least 85% of the amide linkages are attached directly to two aromatic rings. During the 1990s, an in vitro test of aramid fibers showed they exhibited many of the same effects on epithelial cells as did asbestos, including increased radio-labeled nucleotide incorporation into DNA and induction of ODC enzyme activity, raising the possibility of carcinogenic implications. However, in 2009, it was shown that inhaled aramid fibrils are shortened and quickly cleared from the body and pose little risk. Production. World capacity of para-aramid production was estimated at about 41,000 tons per year in 2002 and increases each year by 5 to 10%. In 2007 this means a total production capacity of around 55,000 tons per year. Polymer preparation. Aramids are generally prepared by the reaction between an amine group and a carboxylic acid halide group. Simple AB homopolymers may look like NH2-R-COCl-N- plus N hydrogen chloride. The most well-known aramids are AABB polymers. Nomex, Teijin, Konix and New Star contain predominantly the meta-linkage on a polymetaphenylene isophthalamides. Kevlar and Twaron are both p-phenylene terephthалamides, the simplest form of the AABB para-polyaramide. Ppta is a product of p-phenylene diamine and terephthaloyl dichloride. Production of Ppta relies on a co-solvent with an ionic component to occupy the hydrogen bonds of the amide groups, and an organic component to dissolve the aromatic polymer. Prior to the invention of this process by Leo Valbracht, who worked at the Dutch chemical firm Odzir, no practical means of dissolving the polymer was known. The use of this system led to an extended patent dispute between Odzir and DuPont. Spinning. After production of the polymer, the aramid fiber is produced by spinning the dissolved polymer to a solid fiber from a liquid chemical blend. Polymer solvent for spinning Ppta is generally 100% anhydrous sulfuric acid. Appearances: fiber, chopped fiber, powder, pulp. Other types of aramids. Besides meta-aramids like Nomex, other variations belong to the aramid fiber range. These are mainly of the copolyamide type, best known under the brand name Technora, as developed by Teijin and introduced in 1976. The manufacturing process of Technora reacts ppd and 3,4-diamino-diphenyl ether with terephthaloyl chloride. This relatively simple process uses only one amide solvent, and therefore spinning can be done directly after the polymer production. In Europe, there is a pod known under the brand name Arcelon, which was developed in the beginning of '70s at Research and Production Association Kimvolokno. Since 1975, Arcelon, based on polyphenylene-1,3,4-oxidizole, is produced at OJSC Svetogorsk Kimvolokno. This fiber made from terephthalic acid, hydrazine sulfate and oleum. Arcelon fiber can resist 250 degrees Celsius and withstands short-term heat shock at 400 degrees Celsius with no shrinkage or melting. LOI of Arcelon 30%. Range of products based on Arcelon: filament yarns, staple fiber, milled fiber, spun yarns, non-woven felt fillers, FR fabrics and ready-made PPE. Bag filters for hot gas filtration. Aramid fiber characteristics. Aramids share a high degree of orientation with other fibers such as ultra-high molecular weight polyethylene, a characteristic that dominates the properties. General good resistance to abrasion. Good resistance to organic solvents. Non-conductive. No melting point. Low flammability. Good fabric integrity at elevated temperatures. Sensitive to acids and salts. Sensitive to ultraviolet radiation. Prone to electrostatic charge buildup unless finished. Para-aramids. Para-aramid fibers, such as Kevlar and Twiron, provide outstanding strength-to-weight properties. High Young's modulus. High tenacity. Low creep. Low elongation at break. Difficult to dye, usually solution-dyed. Uses flame-resistant clothing, heat-protective clothing and helmets, body armor, competing with P-based fiber products such as Dyneema and Spectra. Composite materials, asbestos replacement, hot air filtration fabrics, tires, newly as sulfurin, mechanical rubber goods reinforcement. Ropes and cables, wicks for fire dancing, optical fiber cable systems, sailcloth, sporting goods, drumheads, wind instrument reeds, such as the Fibrocell brand, loudspeaker diaphragms, both all material, fiber reinforced concrete, reinforced thermoplastic pipes, tennis strings, hockey sticks, snowboards, jet engine enclosures,